Okay, this is Hw11 and I'm doing homework 11 question 2. And here is my answer and let me tell you how to do it. Okay, for the second question, we need to get some suggested that the following functions of v. And we have several questions that it is 3 questions and with a graph that it represents an autocorrelation function of a WSS stochastic process by setting v equals to tau, or a spectral density function by setting v equals to omega, or both. So we need to see which the functions fv may represent either or both, and we need to get the proof and explain it. And for the first function, fw equals to the e with a square that minus absolute value of v. And we can see from the process that if r tau is autocorrelation function of a real WSS, the calculatic process xt, then it is even, and r tau, which is smaller or equal to r0, and its Fourier transform is non-negative. And if S omega is a power spectrum of a WSS process xt, then it is a negative. This is common source that to prove each of the function whether it is presents either or the both. And for the first one, we can see that it may represent an autocorrelation function because e squared with a negative absolute value of v is even, and we can also see its Fourier transform equals to 2 alpha, which is added by the alpha square and added by the omega square, which is non-negative. And for the next part, it may represent a power spectrum also because the e squared by the negative absolute value of omega, it is guaranteed that it is larger or equals to 0. And for the second one, the fv equals to the sine v square that added by the v square. We can see it may represent an autocorrelation function because it is even, and it has a upper boundary that the limitation when tau get closer to 0 and the function get closer to the 1. So we can see that it is non-negative. And also for the second part, it may represent a power spectrum also because sine omega square is added by the omega square, that it is always larger or equals to 0, which is a non-negative function. And for the last one, we need to prove that the fv, which equals to 1 when the absolute value v is smaller or equal to alpha, and for the other parts, it equals to 0. And it cannot represent an autocorrelation function because its Fourier transform is 2 multiplied by the sine alpha omega, which is divided by the omega, which is not non-negative. So we can see it can't be an autocorrelation function. And for the next part, it can also be represents a power spectrum. It is because f omega is larger or equal to 0.